Okay, let me record.
Okay.
So I will suggest you also copy one more chat room in case because now Zoom limit our access on the chat room. So in case just I believe less than 1 hour, in case this chat room has been cut, you may probably access this one, yeah, this one. Yeah, it's the same. So anyway, but try to access it and then we start. Okay.
No worries.
Okay. Let me open it and share. Yes. Okay. So okay. So send the commas. Okay. We just start, so everybody didn't miss anything. Okay. So
Yeah.
welcome and good evening. And tonight we are going to just do some revision on your quizzes topic. And I send an email and request your questions for tonight. And some of your classmates, especially as Tanfania, right? I haven't pronounced wrongly. If I did, I'm sorry about that. Yeah.
That's all right.
Yeah, okay. So she proposed some of the questions. So tonight we are going through this one by one. But hopefully my answer is correct. But anyway, I would just want to show you about the logic and the step when you handle such kind of questions. So just want to make sure if everybody can see my screen. Now I open the PowerPoint, my file. Everybody can see my screen?
Yeah,
okay.
I can see the screen.
Okay, then tonight we are going to review one of the example at your textbook. It's about chart, the normal chart, and just give you some revision on how to make use of this chart and about the question 7.9, 7.10, 8.1, 8.2, 8.4. Actually, for 8.1 and 8.2 is quite is correlated, and so when we did it, you need to do it together. Okay, just every time I did the preparation and send the Q&A, the answer to professor for double check for accuracy. But this time, I'm sorry, I don't have the time to double check my answer. Hopefully, my answer is correct. But if in case in the later time, professor inform me I have some mistake, and also I will let you know at once. Okay. But now I just keep my answer as correct to share with you. Okay. But at the same time, when I explain or share my thinking, if you don't agree, we can also discuss. So first of all, this is this example appears at your textbook, and is a figure 9.11b, and that is a natural gas boiler reading 9% fuel gas oxygen percentage, combined with a stack temperature rise of 250 degrees Celsius, gives exact air of about 70% and an overall combustion efficiency of about 77% HXP, or 77%. This is the LHV. This is not a typical question, but just give you some number, and those number you can check from the chart. So let me illustrate it one by one. First, this sentence gave me the reading of the fuel gas 9% oxygen. So every time we start from here, the fuel gas percentage of oxygen, we start here 9%. And we draw a horizontal line that touch with this curve, and is the first point. And when we draw a vertical line, vertically, and we will intersect the point or the line of the percentage of the total air, then it will give me the first indicator of the percentage of the air. Right now, in this chart, is 170%. So if the question asks you, what is the percentage of the total air, then you can simply answer 170. But if the question asks you, what is the excess air percentage, then you can't answer 170. You need to put 170% minus 100%, that is 70%. That is shown in this way, excess air of about 70%. So it is the first indicator. When we draw along this vertical line and we touch another intersection point, this intersection point is intersect with the stack temperature. So just let you know, we all the times, if you want the boiler efficiency increase, higher stack temperature is not the favorite one. Okay, I mean, if we can have lower temperature, that means more energy is used in the is applied in the useful way rather than waste. But if the atmosphere, the stack temperature is high, that means much energy will go to the stack and heat up the material, heat up the atmosphere, and let the temperature raise. So you may find that this stack temperature from the top is 100, 150, 200, 250, 300, 350. Along go downward, the temperature is increased, the value. But for the efficiency, is in the opposite. Lower the number is the lower value. Higher position with a higher value. So if the stack temperature is lower, then this line will go upward, then you can obtain a lower stack temperature and with a higher efficiency. So just want to let you know, this is one of the parameters how to determine the efficiency of the boiler. Okay, so we have another point. We need to put a stop because they intersect the stack temperature. Okay, after we put this stop, we need to draw a vertical line, the vertical line, and this vertical line, let me see if there is anything need to tell. No, okay. Why 250? Because here is 250, okay. And the horizontal line, then we draw vertically and touch with, depends on what fuels you use. If you use natural gas, this line will be what we need to take a look. It's 77%. It's the efficiency of the high heat value, okay, not low heat value. So, but if you want to find out the low heat value from the equation, that is the efficiency of the high heat value over K. K is a constant, which also depends on the fuels you used. Let's say the natural gas is 0.9, then 77% divided by 0.9, then you can get 85.6% of LHV. That is a low heat value, okay? So I just want to go through this chart and let you know what parameter you can find, and if in the future application, in quizzes, in midterm, if you are given those parameters, how you use it and find out the efficiency. Or if you have the efficiency, how do you find out like the temperature, like the excess air percentage, whatever. Okay. So any question on this chart?
No, for
Okay.
me it's clear.
Okay. Okay. Okay, then great. Okay. Okay. Next. So it's a 7.9. It's about the electric motor and drive. A 40 kilowatt motor with a load factors of 75% and an efficiency of 89.3% will be replaced with a 30 kilowatt motor with a load factors of 100% and efficiency of 93.6%. How many kilowatt of the power saving will be obtained from this project? Okay, it's a case and before and after. We need to compare. And after compare, we know about the power saving. That is this question asks us to find it out. Okay, the first of all, we need to recall the formula. This formula is about, don't take the whole, don't look at the whole equation. We need to take a look on power, load factor, and efficiency. That is, we have also handled a similar question in, I don't forget this, I don't remember, 7.4 or 3, something like that. How we make use of the load factor and efficiency and find out the power output. Okay, so here is what the equation we need. But of course, now we have two scenarios. One is the conventional one. Another is the new proposal, replaced by a 30 kilowatt motor. So from the wording, you may know that first you need to know what is the load factor. Load factor is how much the capacity of the motor is being used. Because the motor can drive a much higher power, but in the continuous running or operating of the motor, it may not take 100% all the times. In this case, 40 kilowatt motor only take 75% only. And efficiency is 89.3, okay? That is the efficiency and the load factor. Efficiency is defined by the output over input. That is the efficiency. And the load factor is how many portion or how many percentage of the motor is being used. Okay, so it will give you a formula of that. Okay, so by putting the number before and after, or here is standard and improved, then we can find out the power saving. Just put the number like 40 kilowatt motor, 40 kilowatt, 75% and 89.3%, then you can obtain the power saving. Okay. Any questions?
No, my question was more about the load factor, but I think it's now clear because that concept wasn't 100% clear to me.
Okay, that's very good. I tried to find out the reading from the book. A moment. If you still, you know, now it seems it's okay for you to handle this because I have list out the question, list out the formula. But
Yeah.
if you get confusing, you can take a look on your textbook, page 283. 283. It's about the load factor. Actually, for this equation, is the power input to the motor for this equation. And this kilowatt is a nameplate kilowatt. So all the times nameplate is the power is printed or engraved at the housing of the motor. And for this, you can take a look on this page, and it explains to you what is the load factor, but of course the efficiency. I'm pretty sure you know about it. So if you just very simple concept is let's say I'm a strong guy. I can lift 100 pounds weighting, but this time I just lift up 50 pounds only, but I need to handle this and running for the whole day. So the load factor is 50%. Okay, I didn't make use of my own whole power to lift up 100 pounds weight. Okay, that is the concept of the load factor.
Yeah,
okay.
It's clear. Thank you so much.
Very good. No problem. Actually, for 7.9, I also did the tutorial. This question in you can check. And I'm not sure. It's a tutorial. The previous one. Then it seems we have a little bit touch on this question. So anyway, if you still have any question on whatever like this question, you also can simply email to me. Okay. So no, you're welcome. And let's take another look. Take a look on another question. This is the question we haven't done before. And let's take a look on this question. A 10 kilowatt centrifugal fan is supplying 900 liters per second on a very hot day. But on a cooler day, the VFD is variable frequency drive. Drop the fan speed down to where it supplies only 600 liters per second. How many power is the fan motor supplying for the new 600 liters per second? So this question is, assume we are in a very hot day. Hot day, you need to have a strong fan and make you cooling down. So that is the case. You have a 10 kilowatt centrifugal fan and supplying a pretty high flow rate is 900 liters per second. But in the summer, in a hot day, you need such large flow rate, high flow rate to keep your body cool. But in the cool day, you don't need it. But we still need to have some fresh air, but don't need to have so much. So if we install the motor can be adjust the speed. It is a variable frequency drive, can adjust the speed is adjustable. Let's see, we only need 600 liters per second, that is fine. So this question is ask you to figure out what is the power difference. Okay, so that is very important because maybe in your project, you are study a building, I'm not sure, but building should have the pump to pump the water, to pump the air, okay? The pump with the motor all the times. So when the motor is adjustable, so you will know what is the relationship between the speed and the power. Then you can know how much power you can save. That is the question. I think this question is quite worth to discuss because after you go for it, you will know if I decrease 1% of the speed, how many power I can save. Then that is the point we can take a look on this. Okay, first of all, the flow with the direct proportional relation with the speed. That is the first one. Okay, and the second one is the pressure and the flow and the speed. Is a flow square the relation, I mean the nu and O, and which is direct proportional to the pressure. Okay, and about the power, which take log square is the quick. Okay, so now we know the flow rate. So that is this one, and we can easily calculate the relationship between the power and the flow rate. So by putting number here on this formula, 600, the new one, O1 is 900, and in the very beginning, we know this centrifugal fan, the power rating is 10 kilowatt. So we multiply by 10 kilowatt, and we can get the new power. I mean, the power which with lower flow rate driven is 2.9 kilowatt only. So you can see that the portion of the flow rate just drop a little bit, but compared with 10 kilowatt and the new power is 2.9, it dropped a lot. That means the power saving is quite a lot if you just did a little adjustment on the flow rate or the speed of the thread. Any question?
No.
Question?
No. I think it's clear now.
It's
I was
okay.
confused about how to use the affinity loss in this case, but yeah, now it's clear.
Okay, very good, very good. As a conclusion, in motor and drive, you need to handle not quite complicated formula and issue, just a concept. You need to know the load factor, efficiency, of course, the power factor. Sometimes they will ask you, and this relation not much will ask, but in my, as I remember during my last midterm last semester, when I studied this subject, I also have been tested about this such kind of relation. But I didn't mean I don't mean the quizzes you are going to take will have this question, but this concept you can think about it, and it's very useful because the
it's
speed
more
and the
about the
power
concept.
saving.
Yes,
Right.
more the concept that it wasn't clear for me.
Okay.
Now it's okay.
Okay. Okay. I'm glad to hear that. Okay. So next one also proposed by you, and it's about the HVAC. We need to estimate the total heating load caused by 22 people. But among these 22 people, they have different activity. But of course, if the person could sit down and quietly just thinking or writing, they just he or she just consume a little energy. That means the heat gain from them it is not so high. But if I doing exercise, of course my body temperature will increase. That means I release a lot of heat to atmosphere, and my total heat gain will be increased with a larger number. So in this question, there are 22 people, including 6 overhead personnel. It also clearly stated primarily sitting down during the day. Not sure if they just sit, but I'm sure they just sit down and do some paperwork. It's very little work loading, and I mean physically. So from this table I also get from the textbook, and sit at rest, sit writing, sit typing. But of course, you can pick the sit and writing, sit and typing. But I just put a sit at rest, just sit.
Okay.
Maybe yeah. But
Yeah, so
maybe I'm wrong. You can pick 130.
yeah, my confusion was which one to choose. Like, I don't know. They didn't specify what they were doing, but
Yes, actually, yes. You can pick sit and typing, sit and writing. But I just show you the concept on how to handle this. Is my focus is not the number on the final answer, but just let you know how this number is obtained. Is obtained from this table, and where is this table is from the textbook. Okay.
yes.
But of course, aiming to this question, maybe you pick sit and typing is more appropriate, because in the real case, if you have three choices, one is 140 is typing, one is 130 is writing. If I were you, or in the future you are an engineer or energy consultant, you need to propose something. I'm sure I will take 140 instead of 115, because I need to make sure my proposal is sufficient, the power from my proposal is sufficient to fulfill the condition.
Yes, it's like the worst case scenario.
Right. But this question, because I do it quite in rush and just show you the concept. So I just
Thanks.
take 115 and 6 people times 6, and also 4 maintenance personnel and supervisor. I assume them, they are normal walking, because supervisors, right? They do not need to do much heavy work, right? Supervising. And maintenance personnel is not a guy to do assembly, just maintenance. You know, the job is not so heavy. So I just pick a light machine work and normal work, walking, 295, okay? But another group is 12 people doing a heavy labor. I just take the heavy work, but didn't consider machine work, because I don't know if they are machine or do the machine work or not, but just pick the heavy work, 440. Then for this heat gain is divided per person, okay? Per person. So I multiply the number of people to the heat gain and obtain the power. And we sum up all the heat gain from different position of staff, and we can obtain this number. Okay?
Yes.
Okay, so let's take a look on another questions. So it's this, you need to make use of the first answer to answer that. But anyway, we just assume this number is correct. If the HVAC system that removes the heat in problem 8.1 has a curve of 2.0 and run continuously, how many power will this load contribute to the electrical peak if the peak usually occurs during the working day? Assume the motor in the HVAC system are outside the conditioned area and do not contribute to cooling load. Okay. So from this question, we clearly primarily know about the COP, the curve of 2.0. So in our mind, we need to refresh the formula of COP is equal to power heat removed over power electric input. So according to this formula, we have 2 on COP and we also have the heat remove. That is 8.1, this number, and we can easily calculate the electric input of the HVAC system. Okay.
Yes.
Okay.
Yes.
So about 8.4, which is a separate question. It's not related to 8.1 and 8.2. And 30 kilowatt air conditioning unit has an EER of 6.3. And what is the COP of that unit? And for this question, you also need to refresh what is the definition of the EER and what is the formula. So I just simply list the formula. The part we have 10 minutes more. If in case we are cut, then we need to access the chat room of the link, but hopefully we can finish it. And the power input over power the cooling, then 3.6 over ER. And because now we have the ER, we also need to find out the COP. So what is the relationship between the ER and COP? That is a 3.6 over ER equal to 1.0 over COP. That is what we need, this formula. And we just simply input 6.3 to this equation, and we can obtain COP. That is what we did in this table. Okay, any question on that?
No, it's okay, very clear. Good. Like it just wanted to confirm.
Okay. Okay. I also need your confirm because we have the same answer. That means okay. So we have 6.3 for ER. We also have 1.75 for COP. Now we have the power for cooling. We need to find out the power input, the question. So neither you can make use of this relationship because you also have the ER, or you will make use of a COP that we have just obtained and get the answer. Again, we put the power cooling is 30 kilowatt and COP is 1.75. Then we can get the power of the input. Any question on this?
No.
Okay.
All clear.
Okay. So about the question, that is what I received your all the question, and I have reviewed it. Any specific topic you need me to go through?
No, I was having trouble with the HVAC because I don't know, it was kind of confusing, but now like I can continue.
Okay.
Like I don't have like more doubts now.
Okay, very good. Okay. And anyway, you all still have time because on your quizzes is midterm or quizzes, I don't know. Yes. It's on Thursday. So what topic you need to cover is the motor and drive, HVAC, and boiler, right? 3 topics.
Yes.
Lighting.
3.
How about lighting? No lighting, right?
No, he said that lighting is not in this quiz.
Okay, but just want to make sure you understand because I also read the how do I say? It's not a PowerPoint. I also have reviewed the to-do list and or some of the point, and you can't miss the concept of the
Of the heating with the lighting.
not the lighting. I mean some
okay.
of the basic or fundamental knowledge, like what is a simple payback, what is the ROI,
yes, financial.
yeah,
Yes.
and also what is the emission, how you calculate the emission,
Yes.
and some fundamental concept. What is the kilowatt H and the kilojoule, gigajoule. For such concept, you always need to test or stick in your memory. Okay.
Yes.
Okay. And I really don't know what answer will be appear in the quizzes, so I can share with you. But I hope I believe you all can do a very good job. I don't worry about it, because from your attendance of the tutorial and also from your question, I believe you have put your effort on this subject. And all the best, and hope every one of you can manage the questions. And Sen, yeah, you're welcome. And Sen, I have received your email about the Excel, but I'm sorry, today I'm quite busy. I don't have time to open the file and review it, but I will do it in a later time within this week.
Okay, no problem.
Okay. If you don't have questions, then maybe I leave you have more time to spend with your family or do the revision. And if you still have any question, you are also welcome to email me or ask me anytime. And I hope I can do my best to answer all your questions. Okay.
Thank you so much, Ben. No,
Okay.
for me, I'm fine now. I can continue.
Very good. Very good. Okay. So have a good day. Have a great evening.
You too. Thank you so much.
Okay.
Bye-bye.
Bye-bye. Bye-bye.
Thank you.
Bye-bye.
Bye.
Thank you. Bye-bye. Bye-bye.